This is a graphic you commonly see when people start introducing the concept of BIM, building information modeling. And there's another way you could use this term kind of interchangeably, building information management. And I think management is really a more accurate term. Modeling seems to say that we're just making these 3D constructs, but the BIM process is really a lot more complicated than that, or actually a lot more robust, I guess would be a better way to say it. So here, just the idea here is hold that construct that we have all of our data in a file or a shared set of files about the building that we're undertaking. And that happens at the very beginning, the original programming of the project to its conceptual design to when we start, as we'll learn, to move through detailed design. But because of this idea of having this really complex, sophisticated, robust model, we're allowed to do a whole lot of other things with it, like do analysis. For instance, we can hand it off to structural engineers and they can add the steel and analyze those steel components to make sure that we have the structure we need. We are fully prepared to quickly document our building because we can slice through it and make all kinds of technical documents for people to either quote on and or use for manufacturing or construction. In very sophisticated processes, our model can be handed off to fabricators to make custom components. And then this world continues to, I guess, expand, and the circle gets larger to incorporate more things. BIM is now, and this is where it goes from building information modeling to building information management. We get into the idea of using the model that we created or the model as it develops through the process to drive the construction through phasing, through modeling, through figuring out the logistics of ordering components when crews show up, all the kind of logistics. And then furthering that even beyond that is once the building is constructed, this idea of a digital twin. This building exists both in the physical world and also as a digital model. And there's a lot of reasons why we'd want to be able to capture all that information that went through the process of building and in the final product in order to be able to do things like make renovations, to look at optimizing energy performance, working through changing floor plans, modifications to the building, and even to renovations and or even demolitions. So it goes through the total life cycle of a building. And so this process is becoming more and more critical. And as architects, we only participate in certain aspects of it. Obviously, we don't participate in all of them, but we are one of the principal people that constructs the original BIM module, I guess, or model that we're going to work from. So it's really important that we understand this and we use it as a, I guess, a critical component of our process. And another way of looking at this, instead of the circle, is to kind of straighten this thing out. This is kind of a relationship between the architect and the client, from conceptual design through schematic design, which is laying out the programming and the way the rooms might relate to each other, through design development, where we actually start constructing a model of a building, through creating construction documents, which you'll touch on in this course, and then later on in construction tech in your construction tech series. What's important for you to understand, I guess, in the bigger picture is these what I've put in green here, and I actually, up until this year, I almost left it at green. I said that these were BIM leveraged activities. And it really occurred to me that all of this now, the whole line of it, is really BIM focused as far as the world is evolving. And I'm really going into the future here a bit. There are a lot of projects where construction bidding and construction administration may leave the BIM model in the background, so to speak, because the layers and the size of the project may not be of the scale. But in large-scale projects, it's going to become more and more focused that this model that we create follows us all the way through the process. And so you're going to see in the green, most of the time what you'll see to be BIM is the green. This idea of design development and just starting to touch into this idea of construction documents. But in practice, you're going to find that BIM is going to follow us all the way through this whole process. And it's going to be really critical that we understand it and know how to use it and enjoy using it so that it becomes an effective, integral part of our success as architects in general and in your own personal experience as becoming an architect. So I've got a bunch of slides here. This is the kind of the way BIM is usually presented to people for the first time. The idea of BIM creating really accurate communication by actually making physical models. And these are kind of humorous mistakes from not having a model, but working just from drawings. For instance, on the left here, there's the idea that somebody's called out the word kitchen and made a cloud around it, a revision cloud is sometimes it's stated as. And then somebody actually saw that as a hole cut out in the floor and made a hole cut out in the floor. The other thing is the stairway here. This is 3 steps going up to a landing, but the person who poured the concrete read this as the label or the takeoff for this detail, read that as being a line of a step and actually physically created that step. So these are really just to point out that idea of the problem with not having the usefulness of a really physical model in order to create our understanding of our projects. But in more practical ways that we can all understand is that buildings are really complex systems, and so this is a great example of the digital model and the real world model. And you can see all of the plumbing, HVAC system, all the stuff that needs to be hidden up above the ceiling systems in order to make this a functioning building with bathrooms and environmental control systems and all kinds of communication systems. And one of the problems that happens is because those elements are all running so closely together and they're all trying to share the same space, and some things get added on later on, is this idea of what's called clash detection, where somebody will design 2 components to exist in the same place at the same time. And so by making a real world model and not a drawing, not a 2-dimensional drawing that could be easily misinterpreted, we're able to identify very quickly these kind of clashes. For instance, pipes running through other pipes that are exactly at the same level, or in this case, up on the right-hand side here, a pipe running through a beam. And so those can be quickly visualized, and actually the software can help us to catch these clashes by flagging them for us so that we can correct them before they become costly mistakes. Another nice component, new element of this idea of building information modeling is the richness of the components that we can place in. When we place a window in our model, the window is a smart component, and I'll try to detail this idea of smart components in a couple of other components that I show you. But we know its physical shape, its dimensions, what materials it's made out of, those are all carried with it. Its appearance, texture, so that it can accurately render in the model. Its thermal properties, how much heat it'll loss, how much transmittance, how much light it will let through. And it can even become much more sophisticated in the future, and I'm sure it will, down to cost, count, location in the building, and then vendor information. It could be, are they on order? Are they coming? The model might know if where the logistics of the components are actually in the project. None of the last things really mean much to us, but this idea of being able to understand thermal properties and light transmission, and also the appearance and texture of the thing to create an accurate rendering, are all really important to us to create great-looking models and well-analyzed models as far as things like heat loss and whether we have enough light in the building to meet code, so to speak. So here's a good slideshow that kind of steps us through this idea of BIM modeling also. And this is a really critical, image to kind of step you through really the historical idea about when making drawings and making communication documents to help us make buildings. And so you can think back into the early parts. Well, actually, this goes way back. So let's just start in the 70s. Or early or late 60s, where we were actually drawing on vellum on paper to communicate the wall that we wanted to construct. In the advent of the computer in the 70s and into the 80s, we were able to digitize those lines. They were still 2-dimensional. And that was kind of the limits of what we could do with CAD, because the sophistication of computers, the ability to model in 3 dimensions was very limited. Although there were some programs happening like that, it was definitely not mainstream. In the 90s and into the early part of this year, three-dimensional modeling became the norm. Where we were, so in this case, this is a continuous duplicate of a wall system or the representation of a wall. And so we spent a lot of our time being able to actually physically make a model that had walls in it in three-dimensional space. And, for a lot of people, everybody thought that was kind of the end of the story with digitizing things. It told us a whole lot about where walls went and what they looked like. But building information modeling is kind of that next step. And in this case, the walls are now smart. There's all kinds of information, richness in the model of what kind of materials it's constructed of, even to actually bore down and slice through them to see what they're in a cross section, to see what they're constructed of, how much surface area they have, what they're connected to, how they define rooms, a whole lot of things which will be part of what we go through in this course to learn about. And then I'm going to take you through this relatively quickly. It's almost like it seems to you, since you haven't learned the old way, that this is the way things are done, but they haven't always been. And this is where we are in a world of, I guess, a real time-saving tool by using the BIM modeler. It used to be we would draw in CAD. We would make an elevation drawing or a plan drawing of a building and then build elevations off of it. If we decided to make changes to those drawings, all of the drawings needed to be updated. So we would update the plan. We would go back and update the two elevations every time there was a change. Now, when we're working in a modeling environment, as you know, if we change the model, all of the elevations will automatically update. So we make changes in one place, and all of our construction documents and communication come off of them seamlessly, so to speak. And we're not talking about, in this case, we're only looking at, well, you're saving, doing one or two extra drawings. But in fact, when you're in a really complicated building, that could mean hundreds of drawings. So the time saving is immense. So this is kind of an animation. You've already started to do this in our project. But once again, we have a floor plan, a section of a wall cutting through it, and then the elevation, the exterior view, and a 3D view. And the idea here is I'll just go through these slides, and also a window schedule, which tells us what the window sizes are for us to order parts and for the contractor to know what to place in an individual opening. So you'll notice that if we go from, this drawing to highlighting it, it highlights in all three places, or all four places. If I make a modification to move that, they move. So if I flip between these two slides, you'll see the location is moving. And you'll also notice, because the dimension is connected to the window, the dimension automatically updates too. So just by moving the window in one place, it automatically takes care of it in all of your drawings. Likewise, if we were to change the size of the window, which we've done, okay, and you can see by flipping between that, you'll notice now how the width of the window automatically updates in the window schedule. So we're not going back and having to update in multiple locations. And then once again, this idea of, I think this was the last one, where we actually just deleted a window and the schedule just got shorter for us. This is another great kind of animated graphic of that whole idea of BIM modeling and the power of it. This is from those slides. I thought that they were just nice looking graphics. And they say also it's not just a model, and that's kind of where building information management is really almost a more appropriate term. So what this graphic is really illustrating is that while we think that we're managing a model like this, components and elements, they're really all tabular data. They sit in a database. So if a wall is a foot long and 2 feet high, it is listed as data, and when we ask to look at it, it takes the data from a table and reconstructs the elements for us. So that idea of it not just being what we think is a three-dimensional entity, it's really just numeric data in a database. And I'll try to make that hopefully more understandable as we go through the program. Once again, a lot of information. So here we have an example of a door. We've already looked at these windows that we placed in, but we know how we can modify all of these elements of the door. It's parametric, which means if we change dimension, the whole unit automatically updates to the right size. all kinds of things that we can quickly and efficiently get to. We can also import components from other vendors, saving a lot of time in having to construct them ourselves, and then having that kind of linkage back for quoting and estimating. And this is just that same visualization I showed you before, actually almost identical. It looks like it's using the same graphics and just a little different presentation. So this is a term that's always bandied about, that when people are building projects, these are the things that make them the most uncomfortable. Cost uncertainty, timeline uncertainty, not knowing how much effort's going to be needed into it, how long it'll take to construct it. Because many times when projects are getting the green light, so to speak, to be constructed, a lot of money is passed from the bank to the contractor. That is the responsibility of the owner, obviously. And when money starts being spent and no revenue is generated, it's a really uncomfortable situation for a lot of people in the project. So this idea of creating predictability is really important to people. And this helps to, I guess, help create that kind of sense of confidence and better and more advanced planning. So I'm going to step you through this idea of like a model that gets built up from the ground up. So this is a BIM model. We've already started making these foundations. So a lot of this should actually be kind of familiar to you. You can see these little pads like we put in to support our steel columns. We have some foundation walls going through here. And then this is a step through the construction. So they pour the pads for the steel. They pour the floor decks. You can see the steel beams going in. You can see the second floor going up. I think it's the third floor. A lot of cool things. You can see these are the stairwells. This looks like it's a theater over here on the right. The roof goes on. It starts to becoming enclosed. The curtain wall goes up. Curtain wall meaning the exterior facade along the outside of the building is being put on, and then all the way up to the rooftop being sealed in and the parapet being constructed. And then we have more finished detail going in all the way through to actually parking lots, and even parking lots populated with cars. So you can imagine a discussion with the client. Here's what you should expect to see in week 1. Here's what you should expect to see in week 8. Week 10, week 12, whatever it would be along the timeline of the construction of the project, so that it lays out in a time-based way what the expectations are on the project, so that when a client sees a building like this and he goes, you expect to have something done by this time, you can say, this is how it's going to look in the next few weeks. And it builds confidence. It's a way of discussing phasing and construction techniques with the vendors, the people who are participating in the project, a lot of which will become more clear to you as you develop more understanding of what architecture is all about. So I just wanted to introduce that graphic. I thought it was really cool. It's a great way for you to think about presenting your projects to people in presentations also. There's no reason why you can't, that you can hide elements. So really this is just hiding elements as you step back through the project. So you have a completed model, and then you just create new views with hiding certain elements, like the curtain walls, hide the floor, hide the next floor, and so on. So this is a really legitimate way for you to actually make animated presentation material. So that's one part of it, just the management of projects. One of the things that I get excited about in school and training is the idea of being able to do kinds of analysis things. So in the world today, how much material we put into our buildings and what type of materials is really an environmental concern. How much energy the building uses is another environmental concern. And it's also a financial concern, how much money it costs to fuel the building and operate the building. And BIM provides us many opportunities to be able to explore that data, because our model is much more realistic and understandable to plug into other pieces of software analysis. So for instance, this is the full expression, or today, of what, once we create a great model. We can create visualizations to help people understand what we're building, to make sure that they're comfortable with what we are making. I brought up the concept of clash detection elements in the building that haven't been completely coordinated yet, detecting those and clearing them out. Energy analysis, once again, that idea of the building wall knowing how much insulation and other properties it has in it. One of the things that we'll always do, and we'll do a couple of little mini vignettes on it, is to do a light and shadow study, because the model knows exactly where the position of the sun is with respect to where it is facing north and south, and also in the geography where it is placed on the earth. So that idea of energy analysis, extended to energy analysis, can be to make decisions before we have looked at heating and cooling the building to figure out where heat loss is and how we can optimize it. And then we can actually do heating and cooling load calculations to size the heating and cooling equipment that we're going to purchase. And we'll do a little bit of lighting analysis also, and to understand if we have sufficient illumination through the windows to meet code, to make it legible to do work within it. And then we'll have other players that will use our model, like I said, to do the structural analysis, to help us place the steel and size the components. And all of that, including that idea of coming up with the necessary 2D drawings to actually construct the building. Families we've kind of covered already in lab, but there are just a whole host of really detailed kind of objects, BIM objects. And so this one, I don't know if this one is not hyperlinked, but I do believe the next one is. If not, BIM Object is a great resource for bringing in all kinds of componentry. I wanted to just point out this idea of walls. We're going to actually do a lab that probably does a better job than this slide does. But the rich data inside of walls, we're going to build up layers. So in the box here, I've got, it's a little bit blurry, but you can see how it has the masonry brick insulation, the plasterboard or the gypsum wall board on the other side. And all of those things have an R value to them and a thickness. So we can use it to calculate heat loss. So we come up with a total thickness that has a total R value to it. And so there's all kinds of things that you'll be able to, I guess, build into your model to help it make it more useful to other people. And so I'm just picking up on some of these details. Once again, I talked about this idea of analysis. This is inside of Revit. We can actually do wind analysis with a plugin which is called Flow Design. And so in this example, we have our model placed on a site. We made some rough approximations of buildings that are around it. And then we've taken a wind from a direction at a certain velocity and then looked at how that wind picked up as it went through these narrowing spaces between the buildings to find out if we had a level of comfort for people walking between buildings. We'll deal with the sun thing in detail, so I won't cover much of that. And BIM is it's a hot topic. It will continue to be for the next decade of development. The idea of we're moving to like things that happen in the technical world, like for instance the cloud, which is where we are storing our data. It used to be that we would have a server within an office that would hold the data of our model, and then we would send files to other people. Now we're moving to this idea of a shared asset in the BIM model, which means that many people from many different locations, like the structural engineer and maybe the acoustical engineer, can access the same model because it's hosted up in the concept of the cloud, and a place where everyone can get access to it. And so all kinds of webinars and discussions are happening about that. I'll pick up on some other software in the next clip. That was long enough for this one.